trigonometry. Now, yes, okay. So we've got sine theta, cos theta, and tan theta. Yes? Okay, sine theta. So I got two types. I got my sort of triangle, where if this is theta, that's my opposite side. This is my hypotenuse, and this is my adjacent side. Yes? And then if I'm looking at now Cartesian coordinates, this is my r, that's my x, that's my y. You guys with me? Cool. So then sine theta is going to be opposite over adjacent. Yes? Thank you. Opposite over hypotenuse, or y over r. And our cos is going to be adjacent over hypotenuse, or x over r. And our tan is going to be opposite over adjacent, or y over x. This is the easy stuff, right? Very easy, very chill, no stresses whatsoever. Yeah? Okay. Cool. So now, these are the ratios you need to know. You remember your special angles, 30, 45, 60, 90, and 0. Yeah, remember that. Okay. Keep in mind those special angles. I would ideally like you guys to know the values for all your special angles, for sine, cos, and tan. For 0, 90, 30, 60, 45. And then it makes things really, really easy. Okay, cool. Otherwise, just draw your special triangles. You guys remember your special triangles. And then you can just work it out that way. There. Okay?
Special triangle?
Yeah, if you look in your book, where it says special angle triangles,
oh yeah,
you'll find your special angle triangles there.
Okay.
So remember, if you remember that one, it's always going to be 30, 60, 1, 2, square root 3. And that one is just 1, 1, square root 2 with 45 and 45.
Right.
Then if you can at least draw that, you can at least work out all the special angles. Very easy. Okay. Now, the one thing I just need to double check and cover now, get the eraser, is simply reduction formulae, as well as negative angles, as well as cofunctions. Okay. So now, if we look at our cast diagram, it looks like that. Yes? Where we got CAST. I always think, how do you cast? You do this. So you start casting down here, and you go up this way and all the way down that way. That's how you cast something across somewhere. That's how I remember my cast diagram. Start at the bottom right, go all the way across that way. Yes? Cool. Then you know, this just means that cos is positive in this quadrant. They're all positive here. Sine's positive there, and tan's positive there. Okay. And what do we call these quadrants? This is our quadrant of simply just theta, right? We start here going that way. This is going to be 180 minus theta. This is 180 plus theta. And this is negative theta, or 360 minus theta. You guys with me? Okay, sweet. So now, 180 minus theta, if I got sine 180 minus theta, it remains sine theta. If it's any of the other ratios, they become negative theta. And like here, tan becomes positive for 180 minus, everything else becomes negative. And the same thing with cos. Cos is the only one where the negative angle of cos remains positive. Yes? Okay. Also think, because the cos graph is symmetrical about your y-axis. So cos of 20 and cos of negative 20 will give the exact same value. Cool. Sweet. And then your cofunctions, those are very important. This is how I remember it. The cofunction for cos 90 plus theta becomes negative sine theta. Every other one remains positive. Remember that. So instead of remembering each of them individually, remember the one that's different. So if I've got cos of 90 plus theta, it's equal to negative sine theta. Whereas the cos of 90 minus theta is equal to sine theta. The sine of 90 plus theta is cos theta. The sine of 90 minus theta is cos theta. Okay, only one that's different is this one. So remember this one, and the others just sort of become the positive value. This is the only negative value that you get out of co-functions. Okay, you guys get this?
Yeah.
Okay, so the whole thing with this stuff is now being able to apply co-functions and reduction formulae to solve certain problems, right? So they'll ask you tons of other problems where you need to be able to, they'll give you, if they say without a calculator, they'll give you very angles that seem really awkward and funny. But if you can write them in terms of special angles, you'll be okay, right? So if I said the sine of 120, for example, right? That is not a special angle, but I can write it in terms of special angle, right? This is 180 minus 60. So if I say then sine of 180 minus 60 degrees, so now I've got the sine of 180 minus theta. It will just be sine theta. Therefore, it'll just be sine 60, special angle. Yes? So whatever funny angle they give you, you can always write it in terms of special angles somehow. Yes? And if you don't have special angles, you can always they'll find a way to sort of come out and cancel and do all that kind of stuff. You guys with me? Any questions about this stuff in the meantime? Because I want you guys to get this thoroughly, because when you do trig this year, in matric, you're now going into double angles, compound angles, all that stuff. And if you didn't get this, you tend to struggle a bit with matric trigonometry. Okay, sweet. So, can we do a nice example? Okay. So for the last example of the day, can I raise the board? Yep. I'll leave the top as it is. I'll just erase stuff at the bottom. Q. So we got, if sine theta equals negative 13 over 5, and theta is between 270 and 360 degrees, draw a sketch and calculate tan theta and the angle theta. So now it said sine theta is y over r. Yes? So let me draw my little Cartesian setup. So it's negative 13 over 5. So we know that our r can never be negative. R is always a positive value. Yes? So that's to then be negative 13 over positive 5. So my y is negative 13, which is somewhere down here, and r is positive. It's going to be either there or there. Yes? Okay. Now that I said sine theta is an element of 270 to 360. So which one is it then? My fourth quadrant, there. So it's not this one, it's going to be that one. Okay, where do I draw my angle? There or there? Top or bottom? Top. Okay. There. Where now, at this point, my y is negative 13, my r is 5. So now to find my x, what do I do? Pythagoras. Yeah. So if my y is negative 13 and my r is 5, let's draw the triangle. It looks like this, with theta being there. This is 13, this is 5. I need to find x. By Pythagoras, my hypotenuse squared is equal to my x squared plus y squared. So therefore, find my x. X will simply be square root of my hypotenuse squared minus y squared. So I have 5 squared minus a negative 13. Oh, sorry about that. A negative 13 squared. Someone give me a quick answer there.
It's 194.
Gather the answer.
13.9, I guess.
Hello?
13.9.
13.9, yeah.
13.9.
Yeah.
Okay. 0.9 what?
283.
9.3.
Okay. And then let's find, so that's this side here, hey. How is that even possible?
Isn't it?
13.9. But my R is 5.
Oh no, I think it's this way. It's just.
You can calculate it with me.
You have to say
You
minus.
can
Minus 144. You can't get it.
No, minus 1.
Okay, so we have this triangle there. So now we know that x squared is equal to our hypotenuse squared minus y squared,
Square, yes.
right?
169.
Okay.
It is, yeah.
Minus 12. It won't be minus 12. Otherwise it would be right.
I think maybe there's an error in the question. It's meant to be negative 5 over 13. Please just put that correction in your books. It's meant to be negative 5 over 13. Not negative 13 over 5. Okay. So then our R is 13 and our Y is negative 5. I mean, sorry, negative 5 over 13. What am I doing? It's negative 5 over 13. So our Y is negative 5. Our R is 13. So this is 13 here. And this is 5. Sorry about that, guys. 13, negative 5. Okay, what else did you get then?
Then it's 12.
Okay, fantastic. Sorry about that. Okay, cool. And then we need to find our angle theta. How do you go about that?
Y over.
We do inverse trig functions, right? Yeah. So if we've got that, so now we can just say, well, theta is equal to, we could use tan, but I would rather than use the values that they gave us, that if I make a mistake in the previous question, that doesn't affect my next question. So I go, theta is equal to now the inverse sine, sine negative 1 of my y over r, that would be my angle theta. Yes?
Yeah.
Okay. And what else does that give us then? Keeping in mind the new values for y and r. You guys also get 22.6.
Yeah.
Yes. 22.60. Remember, this is our reference angle now, right?
Yeah.
Reference angle is 22.6. Which quadrants is sine negative?
3 and 4.
3 and 4, right? And we're working in this quadrant here. So basically, our angle will be 360 minus 22.6.
Yeah.
Okay, so therefore, and that'll give us 337.4 degrees. You guys with me? Yep. Okay. Sweet. Now the next question is prove the following identity. Just check how we're doing for time. We're doing alright. Can I raise this?
Wait.
Okay. Let me know when you're good to go. Done. Okay. prove the following identity. We have cos theta into 1 plus tan squared theta being equal to 1 over cos theta. Okay, when you're doing identities, start from the more complicated side and work your way to the simpler side. Okay, and the whole time, keep in mind where you're trying to go. Okay, if you're trying to leave here and go to 4 ways, you're not going to start by going that way. You're going to turn and go that way. Because you know 4 ways is in that general direction that way. Okay, so now I'm going to start with this side here, start with the left-hand side. Please, very important, when you do identities, don't write this and then start working on each side. You must say, I'm starting with the left-hand side and then carry on working. If you want to switch halfway and say, okay, well, you're stuck on the left-hand side, then you go start the right-hand side, you go right here and say RHS and start working there. You are allowed to work on both sides simultaneously, and if you get to the same answer, then you've proved it. So I started there something and I get some random answer sine theta, and this says sine theta. That's proved, you've basically proved everything. That makes sense. So you don't have to go from one side and go all the way till you get to the right-hand side, or from here and go all the way till you hit left-hand side. You can start on both sides, and if somewhere down the line the answers look the same, you've proved everything, you're sorted. Okay. So whenever you get stuck, you can then go to the other side and then try work there. It'll help you sort of get close as well. So now, with this, I'm trying to get towards like 1 over cos theta. So I know that tan is sine over cos, right?
Yeah.
So I'm going to multiply this in here and change this already. So cos theta times 1 is going to be cos theta plus sine squared over cos squared, right? Times cos theta. You got sine squared theta over cos squared theta times cos theta. This cancels one of those. Yes?
Yeah.
Okay, cool. Then I've got cos theta plus sine squared over cos theta. What do I do now? LCD,
Yeah.
right? What's my LCD in this case? Cos theta. Okay, so my LCD is cos theta. That's going to be cos squared theta, right?
Yep.
So we end up with cos squared theta plus sine squared theta over cos theta. That becomes 1 by the Pythagorean identity, and therefore we have 1 over cos theta, which equals the right-hand side. Yeah?
Yeah.
Okay, fantastic. And then let's quickly solve the trig equation, and then you guys can do an activity. Okay, solve the following trig equation. Cos of 4 theta plus 20 degrees equals, negative a half for 0 to 360. So we got the cos of 4 theta plus 20 degrees equals negative a half, where theta is in the range of 0 to 360 degrees. Okay. Now, where is cos negative?
Second and third.
Second and third. Okay, so that if we draw a cos diagram, we have it's negative there and there. Right? Okay, cool. So now when we do this, how do I find our reference angle? So to get our so this is plain and simple. There's no sort of funny calculations we have to do at this point or sort of manipulations. We can just take this and find our reference angle for negative a half. Right? So our reference angle is going to be now inverse cos of, a half, and what is that? 60 degrees, right? So our reference angle is 60 degrees. Cos is negative in these two quadrants here. Quadrant 2 and 3. So we say quadrant 2, quadrant 3, quadrant 2 is going to be 180 minus, right? Hello?
Yeah.
Okay, so now here I'm then going to say this angle here, which is 4 theta plus 20 degrees is equal to my ref angle, which is 60 degrees plus K, sorry, not K 360 yet, we're in quadrant 2. That's 180 minus.
Yeah,
180 minus 60 degrees plus K 360. You guys with me? Okay, and in quadrant 3, 4 theta plus 20 is equal to 180 plus 60 plus K 360. Yes?
Yeah.
Okay, and then basic solving through this, that's 120. So now I need to take the 20 degrees across as well. So 4 theta is equal to 180 minus 60, which is 120, minus another 20, which is 100. That's 100 degrees plus K 360. Let me just work this down and I'll do the other side when I'm done. Now I have to divide everything through by 4 to get theta. Therefore theta is equal to 25 degrees plus K times 90 degrees. Okay, and then this one, same thing. We're going to then have 180 plus 60, which gives us 240, right? Minus 20, which is 220 degrees. So 4 theta is equal to 220 degrees, sorry, plus K times 360, divide through by 4. Theta is going to be 110, 55. 55 degrees plus K times 90 degrees. So this is my general solution for theta. They asked us for specific solutions now for the range 0 to 360. Okay? So you start plugging in values of K. Right? So for this one here, if K is equal to 0, theta is 25. If K is equal to 1,
115.
115. If K is equal to 2,
20. Yeah, 205.
205. If K is equal to 3,
295.
295. If K is equal to 4,
That goes over.
that's beyond my range, eh? So if K is equal to 4 is too much. And if K is negative 1, that's still beyond my range as well, eh?
Yeah.
Cool. Let's check this out quickly. When K is equal to 0, theta is equal to
55.
55. When K is equal to 1, theta is equal to
145.
145. When K is equal to 2, theta is equal to
235.
235. It's 25. When K is equal to 3,
320.
That's- 325, yeah.
And then next one
Theta is 325. K is equal to 4 is beyond my range. K is equal to negative 1 is beyond my range. And then to finish this off, this is not your final answer. Your final answer has got to be K. When you do now, listing is an element of, you list the numbers in numerical order 25, 55, 115, 145, 205, 235, 295, 325, and important, K is an element of the integers. Yes? Okay. And that's how you go about that. Awesome. You guys quickly just try the activity question.